Hey guys, today we're going to do a little biodiesel lab. What we're going to do is we're going to take a triglyceride. We're going to mix that triglyceride with methanol, and in a sodium hydroxide catalyzed reaction we're going to make biodiesel and glyceride. And if things go well, we'll be able to use our biodiesel, and we'll be able to maybe use that triglyceride to make some soap. And I guess the next step follows. Stay tuned to see what's next. Alright, good day everybody. We're continuing our biodiesel lab here. And of course the first most important thing about any lab you do is safety. So you need to familiarize yourself with the chemicals that we're going to be using. For that we have the Right to Know information station, or you can look up the Material Safety Data Sheet, or MSDS, online anywhere. So what we're cleaning today, I guess the second most important thing after safety is making sure that your workstation is clean, which is part of safety, and that your glassware is clear from contaminants. So we've got various beakers and flasks, graduated cylinders. We also have a separatory funnel and a burette for this particular lab that we're going to need to clean. And anytime you clean a burette or a separatory funnel, you need to take the stopcock out. Simply unscrew the stopcock, pass it through, and the washer should come off rather easily. Rather than wasting a video working on this blasted washer, I'll continue and tell you that you need to not just wash your glassware, but anything that's going to be in the chemicals. So I'm going to wash this thermometer as well. So I'm off to wash. I'll see you guys in a couple of seconds, but it's going to be a little bit longer than that for me to finish washing. Alright, so what we're going to do now, while my dishes are drying that I just washed, is I need to make some titrant solution. And what we're going to do is we're going to take some sodium hydroxide, measure out about 1 gram of that, and dissolve it in a 1 liter volumetric flask. So to start with, we've got the volumetric flask, we've got distilled deionized water, both. We've got sodium hydroxide, and we have an analytical balance. This analytical balance has been zeroed so that this weighing dish zeroes it out. So now what I'm going to do is take my clean scooper. It's important when you're using an analytical balance not to put a lot of pressure on or around this, because even pushing on this countertop is going to affect your reading. And I'm going to try to do this just a couple of pellets at a time. I am wearing my safety equipment, my PPE, personal protective equipment, because lye is a caustic, sodium hydroxide is a caustic. So 2 is about 1/4 gram. I'll usually gently shake this off. We are at 0.8556 grams. So just a couple more bits of lye here. 0.9, oh, there we go. We are at 1.08. I'm going to take this small portion. Notice I don't put pressure on the scale when I'm dealing with such, because I don't want to mess with the analytical balance. Still a little bit high, so I'll take this over here and I will shave just a smidge off of that. This is going to put us below, I'm sure. We're 0.93, so we need about 7/10 of a gram. So I'm going to slice this bad boy up. Maybe take this original one we had in there. 0.97. So another smidge. Stuck on my glove. We're going to close the analytical balance. And we are at 0.991 grams, and that's close enough for me, so I am going to write this down. 0.9914 grams. 0.9914 grams. Close up the sodium hydroxide. Set this aside. The next step is to get the sodium hydroxide into the volumetric flask. Sodium hydroxide is very reactive. It's caustic, and even as we're sitting here, it's beginning to dissolve just from the humidity. I need to get as much of this in here as possible. The next step is to fill your volumetric flask with water, but not all the way, just a little bit. Just enough to dissolve the sodium hydroxide. So we're going to stir this around until all the sodium hydroxide is gone, maybe add a little bit more. Then once we're done dissolving all the sodium hydroxide, we will fill to the volumetric mark right here that indicates we're at 1 liter, and that way we'll know that we have 1 liter of deionized dissolved water, and distilled water, not dissolved water, and we'll have 0.9910, whatever I wrote down over there, grams of sodium hydroxide, and from that we can calculate the molarity of our titrant solution.